Welcome to the session on Java 8 language capabilities. What's in it for you? My name is Venkat Subramaniam. We're going to talk about the features in Java 8, more specifically, mostly related to lambda expressions. One of the things I want to emphasize is the best time to ask a question or make a comment is when you have it. So please don't wait till the end. Anytime is a great time for questions, comments. If you can just draw my attention and ask the question, that would be absolutely great. So please don't wait till the end. Now, one of the things that really surprises me is for me to even be here to give this talk, because I was one of those guys on the other side of the fence holding the card saying Java really sucks. And to really see that Java actually has really evolved phenomenally is very refreshing. So I'm really thrilled to see these nice features in it. But if you really look back in time, when was the last time something significant happened in Java? Well, right after the original release of Java came along Java 1.1 when we had a few features, and then there was a few other minor improvements, and then the major improvement after that was in Java 5. But Java 5 had some very questionable features like generics and auto-boxing. Java 6 had no features at all language-wise, and Java 7 had one of my most favorite features. You could put underscore in numbers. As I'm aging, that's a feature I really like, right? I don't have to really stare so hard to find out how many numbers are there. Well, nothing really exciting happened in Java, but all that changed with Java 8 with the introduction of lambda expressions. And we're going to talk about what that is in this presentation. So the first question is, what are lambda expressions? Well, lambda expressions are anonymous methods. Well, they're actually cute little anonymous methods. And not only can we do object composition like we are used to doing object composition in Java all along, now we can also do function composition. And not only can we do function composition, we can mix and match object composition and function composition together as we feel. So let's understand what all this means with an example. I'm going to start with an example which is going to be so common that we have written this a million times in our lives so far. And I'm going to make only one small change at a time. And for every single change I make, we're going to go from something very familiar to maybe something a little unfamiliar. We'll get comfortable with it, talk about it, and then we will refactor the code just one more time and see where we go with it. So let's get started with one little example here to play with. What I'm going to do here, I'm going to start with a list of values. Let's call it as list of integers over here. And in this case, we're going to say values equals arrays.asList. And let's start with these little values to work with. And we're going to go ahead and iterate and print these values. Oh, real quick, as you probably noticed already, I don't use any slides in my presentations, which means you don't have anything to take home with you after this talk is over other than the memories, whether they are good or bad. And of course, you would probably want access to the code I'm writing here, but if you're interested in taking a look at that code, you can download them later on from my website here, agiledeveloper.com, and then go to the downloads page, you should be able to download it. So let's get back to the example we've been working with. So what we're going to do here is we want to iterate and print these values. Shall we try? I'm going to say for over here because I want to iterate and print the values out after all. So let's get started. I'm going to say over here for, and I'm going to say int I equal to 0, I less than values dot, is it length? Is it size? Is it length? Size? Are you sure it's size? Okay, I believe you. And then I want to print out values dot get. Hey, that worked. Okay, so what do you think of that code? I'm going to argue that is one of the most complex codes you could ever write. Now you may look at this and say, what, complex? That is simple. No, we're getting confused. The word there is not simple. The word there is familiar. And there's a very big difference between the word familiar and the word simple. This is familiar to the point we have seen it so many times we don't want to see it again. But it is familiar yet complex. Why is it complex? Now notice, you first have to set up the variable initially properly. Then you got to set up the boundary conditions properly. Have you ever had a time when you think, pause and say, is it less than or equal to? Remember that? And when you're done with it, what do you get? You get the off by 1 errors. Have you ever had that problem? So if you're into patterns, I have a pattern name for this. This kind of code is called self-inflicted wound pattern. There is absolutely no reason to do this, right? And yet we have done this for so many years, and we have iterated through the code these many years, but thankfully we don't have to do it. Well, already in Java, there's a different way to do this. And so what we could do is we could say for int element in values, and then we could simply output the value. What a relief. Why is this better? Well, Occam's razor says if you have two solutions to a same problem, and if they produce the same result, you should choose the simpler one. This one is simpler. Why? Because it has fewer moving parts in it. You don't have to spend your time and effort setting up stuff properly. This has got fewer moving parts in it, so it's better. But collectively, these two together are called as external iterators. So what is an external iterator? An external iterator is like having a rude dog at home. You say move and it doesn't move. You got to keep pushing it, right? You manage this entirely all by yourself. Versus we could use what is called an internal iterator. So an internal iterator is where you throw a frisbee and the dog runs towards it. You can put the code on autopilot. You can say, I'm going to tell you what to do for each of the elements in the loop, in the collection, but I'm not going to sit there and manage the iteration. Now, what means is that you don't have to expend the effort in dictating how the iteration is being done. Instead, you focus on what you want to achieve by doing this iteration. This is called ceding control. You're relinquishing some control, and that is a good thing, because by not doing what we don't have to do, we don't have to maintain that code that we don't have to do. And as a result, we can get optimizations quite easily. Let's take an example here. So I'm going to go ahead and turn this into an internal iterator. So what am I going to do? I'm going to say values.for each. Let's stop right there before we write any more code. Now notice the fundamental difference. Syntactically, we haven't done anything different. This is not the first time you're looking at a method being called on an object. So syntactically, we didn't do anything different. But semantically, it's a world of difference. Rather than taking the value that we have on our hand and getting one element at a time and controlling the loop all by ourselves, we are putting this on autopilot. We are saying, hey, collection, I don't care about looping. Go ahead and do the looping for me. That is internal iteration right there. In here, what do? You get exactly what you ask for, which is looping through the elements sequentially, one element at a time, assuming you did this correctly. Whereas here, you said, I want to loop. Well, how are you going to loop? I don't know at this point. This could be sequential. This could be concurrent. This could be lazy. All those options exist. Hey, how could we have all those options? Well, because we're going to use a concept that we so long to use, the concept of polymorphism. Man, what does polymorphism say? Polymorphism says, don't worry about how things are being done. Worry about what you want to do and decide the implementation at runtime. Whether this implementation could be sequential or concurrent or lazy, I don't want to make the decision right now. I want to postpone that decision to a later time. I want to simply focus on looping right now and remove the mechanics of the looping from it. So semantically, we are separating the two parts that have to be separated in here, and we're going to see later on how this could be polymorphic, how we can benefit from this. So let's say how we're going to compute this. Well, in order to write this, I'm going to send something to the for each. Once again, this is something we have done a lot before. I'm going to say new consumer integer right there, and I'm going to create this. What is consumer? Well, consumer is a new interface that is part of Java 8, and so I said consumer is available right here. And within this, of course, I'm going to go ahead and implement this. So what am I going to say over here? I'm going to say over here, the method I want to implement, I'm going to say public, and the method of consumer is called accept. And what does it accept? A value. And what do I want to do? I want to print out the given value. So if you notice, we wrote this code as an internal iteration rather than an external iteration. Now, can anybody tell me what this is? Anonymous inner class. Well, that's what you call it, but I call it missed opportunity, right? They could have avoided this in the first place, way back in Java 1.1, when lambda expressions could have been introduced, right? So anonymous inner classes were used, and we have been working with it for so many years. So I mentioned that this is really good because this can give you polymorphism. It can give you a control over what you want to do, but relinquish the control over how to do it. And I said this polymorphism can be so beneficial. I mentioned so many different things. And I know what you're thinking right now. You're saying, okay, that may be true, that this may be really that good, but in order to realize that good, if we have to write yet another anonymous inner class, heck no, right? Is there anybody in this room who wakes up in the morning and says, yes, I'm going to go to work today and write one more anonymous instance? I don't think so, right? You had a question, please. That's correct. So the for each method is the new method now on collection, and we're going to talk a little bit more about that very soon. So while this is really, really better in a lot of different ways, we all can agree that this code has a lot of ceremony in it. This smells really bad when you look at it. You don't feel good after writing that code, right? So what do you do about it? Well, thankfully, we don't have to write that code. So what we are going to do is we're going to simply say values.forEach one more time. But this time, let's only focus on this code here for a minute, the one I have highlighted. Now, that contains a lot of garbage in it, as we can see, right? A lot of ceremony in it. But what is the most essential part of that code right there? And that would be line number 19. Because line number 19 is what we are saying, I want to print each of the element, right? That's what we are saying on line 19. What else is important? Oh, a part of line number 18 is important, which is integer value. You want to say what's the parameter that you're interested in working with. But everything else around this is pure fluff, isn't it? So what if we can remove the fluff, remove the ceremony? Why? Because what is ceremony? Ceremony is what you have to do before you get to do what you really want to do. Does anybody here enjoy ceremony? Can I do this, please? No, you got to do this other stupid 7 things before you do this, right? Ceremony sucks the life out of us. And that's what we've been doing. So if you have a great idea, look, I could send a function. Oh, to do that, I got to use an anonymous class. Never mind. Can we go to lunch today, please? Right? I don't want to write the stupid code anymore, right? It sucks the life out of us. Well, what if we can do this? All I'm going to do is I'm going to simply say, here is the part, the most interesting part we are interested in. So integer value. And what do I want to do with the value? Print it. So notice we removed the ceremony from this code, and we distilled it down just to the essence of what we want. And now we have an anonymous method, anonymous function. So what does this function say? Well, for each says, I'm going to accept a function, sure. But what is a function? For most of us, we could argue a function has 4 things in it, right? A function has a name, a function has a parameter list, a function has a return type, and it's got a body. Well, given a name, a parameter list, a return type, and a body, of the 4 things, which do you think is the most important? The body of the function. Without that, what are you trying to do? Well, what is the body of the function? The body of the function is the right of the arrow in this anonymous function. So write that arrow that's sitting in front of us. That arrow separates what's on the left to the body of the function on the right side. So that is the body of the function. So the body of the function is sitting right here. Okay, that's 1 down, 3 more to go. What about this one here? That is the parameter list of this function. This says this anonymous function would receive an integer value as a parameter, and you would print it. So we covered the body of the function, we covered the parameter list. Hey, what about the return type? Oh, we can figure that out based on the context. Hey, what's the name? Why bother about the name when everything else is done? It's anonymous. So we reduced this quite a bit, but unfortunately, there is still quite a bit of a noise in this code. So let's refactor this just one more time. Now, let's take a wild guess. If you iterate through a collection of numbers, what would be the type of each number? Do you know it? Absolutely, right? A collection of integers would be integers. So you know it. Does Java know it? Absolutely. Then why the heck are we saying the obvious? That it is an integer, right? The only time you ever say obvious is when you meet your spouse in the morning. I love you. That makes a world of a difference, right? It is obvious, but you got to say it every time you answer the phone. But anything else in life, I would say don't, right? So the beauty of this is there is absolutely no reason to do that ceremony. So what am I going to do? I'm going to simply say value, and I'm going to just go ahead and print out this value that we just wrote right here. So when I run this notice, it doesn't have any queries about it. Why? Because for the very first time, Java is finally intelligent. We don't have to specify the type information. It says, I can figure this out, dude. You don't have to be telling me the obvious, right? It is an integer, so no reason to be sending that over to me. So it figures out that the value is integer based on the context. Well, for simple cases like one parameter, we can refactor this just one more time here, if you will, and we can get rid of even that silly parentheses that we have. And so I'm going to simply say value, and this is going to be simply printing out the value that we have. So notice we got rid of the parentheses one more time, and that reduces quite a bit of ceremony. But this leads to one other problem. If you notice this particular code, if you look what's happening in this code, we are receiving a parameter called the value. And what are we doing with this parameter? We simply turn around and pass the parameter as an argument to this function. Did we do anything with this parameter? Absolutely nothing. You received it, and you turned around, and you passed it. So I've got a pattern name for this kind of code. I call this the Office Space pattern. Remember the movie Office Space? Right? Ted, what do you do here? I take the requirements from the business people, and I give it to the programmers. Like, why can't they do it themselves, right? So that is exactly what this code is doing. And about the 10th time you write this code, you're going to look at this and say, that's stupid. Because all I'm doing is receiving a parameter and sending it. But history has shown us one thing very clearly. Java programmers never write stupid code. They invent IDEs to vomit stupid code. So the next thing you know, people are going to be asking each other, tweeting, hey, what's that stupid shortcut you use in the editor to spit this code out? And these guys knew this was coming. So they said, let's eliminate it right away. So what they did instead was to use what is called a very nice method reference. So you say for each, and method reference can be used only in situations where you have the Office Space pattern, right? Where you don't do any work, any intelligent work, except you're passing through. You receive a parameter, and you just pass through. In that case, what you can do is you can simply say system.out, and then colon, and then you say print line. So this basically says, I want to receive a parameter, and I simply want to pass that through as an argument, no alterations whatsoever to it, and it just passes through. So this gives for a very nice, concise syntax, and this starts reducing the amount of noise in the code. It takes a bit of getting used to. And sometimes people look at me and say, oh, this is complex. Again, they're confusing the word here. The word is not complex, but guess what it is? Unfamiliar, that's correct. But once we get familiar with it, then we get to decide whether it's complex or not. But when we are not familiar with something, we haven't even given it a chance to know whether it's simple or complex. But this ends up being very simple because of various different reasons. Now, we looked at how we can refactor this code. So we started with the very highly ceremonious for loop, and then we made that simpler by using the for each of Java 5. We then went further to use an internal iterator, but then that involved quite a bit of ceremony, and at this point, we haven't seen any new syntax, right? And the very first new syntax we saw is right here, where we used a lambda expression. Then we eliminated the ceremony of type and made it use type inference. We then moved forward and said, hey, go ahead and remove the parentheses. And then we said it's simply a pass-through. Let me go ahead and just use a method reference. Any questions or comments so far? Please.
So in the upper example there, when you're doing the values for each with new consumer,
Good, very good question. So let's talk about that real quick. I'm glad you asked. So looking at this code, let's go through that quickly for a minute. If, let's say, we are looking at this code for a second. So we are looking at this and you're saying, oh, you know what? This is a very familiar thingy. This is simply using an anonymous inner class over here. Now, one of the things they could have done is they could have said, oh, you know what? People don't want to write ugly syntax and a ceremonious code, so they could have done something very, very simple. They could have simply rewritten this fluffy code in a precompiler level to something as simple as a lambda expression to provide this, because syntactically those two seem to be equivalent, right? So your observation is truly correct in this case to say, oh, maybe the compiler will rewrite this, let's say as this. Let's assume that for a second, right? What would happen? What's the consequence of doing that? Let's think about this for a minute. If we have this code right here, which is anonymous inner class, let's go ahead and run this real quick for a second. Well, it ran. Let's do something here real quick. Let's go back here to the command prompt just to take a peek over here at what we have on our hands. So I'm going to increase the font size here in just a second for you. So if I go in here, let's just take a look at what's going to happen right now. I'm going to create a directory output. I'm going to say java c -d output, and I'm going to compile this code sample.java. And if you look at the output directory, you can see that little class sitting in there, right? Now, if I go back, if it was true that these two are verbatim equivalent at compile time, and if I said, for example, value right here, and if this was simply converted to a lambda expression off the bat, then what would happen? Well, every time the compiler sees one of these, the compiler will create one of these. Well, but what's going to happen is, as a programmer though, when you see that it is so cute and beautiful to write, you will never write one of those, would you? You will write many of those. And when you write many of those, what's going to happen? The compiler would come along and say, oh, cool, lambdas for me to convert, isn't it? And what it would end up doing is, it would take that and do that. And when you run the code, it works fine. But then when you go back to the disk and you do java c and you take a look at it, you got an explosion. This will make no friends in the world. So they said, we can't do that. So what did they do? Let's try this one more time. I'm going to go back over here, and instead of doing that, let's just do this for a second. Notice I used lambdas at this point. Let's go back to the disk one more time. Let's compile this code real quick. Now let's go ahead and look at what's in this directory. Isn't that beautiful? You enjoy the silence over here, isn't it? So you're kind of curious, what's really happening? Well, if you look at what's really happening, let's use java p -c. -c is the default on my machine already, and look at what's in here. We will take a look at something that's just really amazingly cool. But before I show you that, I want to share with you a quick story. When they were working on Java 7, they took a mere act of kindness for these other brothers who program in dynamic type languages and said, let's implement a feature to make these languages better. And the feature they introduced was Invoke Dynamic. This was purely done to help these other guys' lives better. I mean, they could have completely ignored this and they could have said, we don't care. But they just took an act of kindness and gave a feature. As they came along to implement Java 8, they said, wait a second, this is going to be a problem. Because if we convert these into anonymous inner classes, we are in trouble. And somebody suddenly realized, oh, wait, we could actually use Invoke Dynamic. And all of a sudden, a feature introduced as a mere act of kindness became the first rated feature for Java 8. In short, what I'm describing is what's called an act of karma, right? This always tells you do good things to other people, it pays back big time, right? So if you look at this here, you can see that it says invoke dynamic, and all these calls simply become invoke dynamic. Essentially what that means is, do not go through the overhead of creating objects. All you care about is the signature of the method. As long as you can roll that lambda expression into either a static method or an instance method, depending on the context, All you have to do is just bind to that method because it's got the right signature for you, bypass all the overhead of creating objects. So this is a very powerful bytecode JIT level optimization that's happening to give you a good performance. And so this is probably one of the best things that I've seen in Java, other than one more thing we're going to see a little later. So I hope I answered your question. That's fundamentally the way this has been done within the language. Sorry? Excellent, thank you. So that is the beauty of what they have done. Really, really impressive in terms of how they have addressed that. Yes, please.
What would happen if you had 2 parameters?
The question is, what would you have if you had 2 parameters? Well, the question is, if you look at, so this is where the type checking really comes in. For each is still accepting consumer, and interfaces like consumer are called as functional interfaces. I always laugh when I hear the word functional interface because it makes me wonder about all the other interfaces. Are they dysfunctional? Anyway, so these are called functional interfaces, right? So functional interfaces can be automatically elevated to lambda expressions. In other words, you can only use lambdas for functional interfaces. What makes an interface a functional interface? A functional interface is a SAM, a single abstract method interface. It can only have one abstract method, but that method, of course, has a signature with parameters coming in. And so if that method takes a parameter, one parameter, you can only send one. If you send 0 or more, you get a compilation error. If that method takes 2 parameters, you can only send 2. You cannot send fewer than that or more than that. Now, having said that, methods like for each are receiving a specific functional interface. For each receives consumer. We're going to quickly see more functions, and when we do, I'll mention the functional interfaces for them. So the functional interfaces define the contract of how many parameters you can send. So if you try to send more than one, you get a compilation error right off the bat. So for example, if I were to say value 1 comma value 2 of some sort, I will get an error right off the bat, and it will call me names, right? And the reason is because I failed conforming to the contract that's been established at compile time. So that's pretty effectively done. Yes, please. That's the next thing we're going to talk about. Excellent. So let's see how we would make use of some of these now that we have refactored this code. So fundamentally, we are going from an imperative style to more of a declarative style of coding. Let's understand this with an example. Let's say we have this collection of values, and we are asked to double each of the values in this collection and to total the values. Fair enough? Double the values and total. So what would we do? We would say for int I equal to 0. No, we wouldn't do that, right? We would say for element E, and then we would say in values, correct? And then what would we do? Total, and then we would say plus equals to element times 2, where we would say int total equal to 0. And then we would output the total. Does that code look familiar? Absolutely, right? And we have all written code like this, right? My question is, how do you feel when you write code like this? Dirty, right? That's the way you feel, right? Because this is primitive abstraction, very low level. First define a variable, then start looping, then multiply, then add. When you're done, right? In fact, this is really, really bad. If you're writing this code, and if you're home, be very careful. If the kid runs around, right, if you're at work and do this, you feel dirty, you go home, kids come running to you, what do you say? Don't touch me. I got to go shower first, right? Those of us working at home, it's even worse. If a kid comes running and looks at the code, the kid looks at it and says, that's what you do for a living, right? And they don't want to take our profession after that, right? So this is very low primitive abstraction. Let's try this one more time. We're going to say output, but we're going to be declarative about this. Let's try this. How do we be declarative about this? Values.stream. Oh, wait a minute. What is the stream? A stream is a fancy iterator. It gives a very many number of functions we could use. Well, we are used to iterators before, but what does an iterator do? Oh, I'll give you next, and I'll tell you if I have a has next. This has some really, really cool features. One of those features is a function called map. And what does map do? Given an element, I can do transformation of the element. In fact, that's exactly what it is. You've got 5 input coming in. I don't want to babysit and say, take the first one, take the second one, take the third one. There's not enough time in life to do that. Instead, you say, I got a collection coming in. I don't care about the number of elements in the collection. Here is a mapping function I want to provide. Apply this mapping function on every single element, transform the result, and give it to me. So this comes from the way we do mathematical expressions, right? What do we say? Given a function f, for all the possible input, here is the possible output. It's a transformation of input to output. So we said transform, and how am I going to transform? Given an element, return element times 2. Then what am I going to do? I'm going to reduce this down, and what am I going to reduce it to? Starting with the value of 0, if I have a carryover and an element, I'm going to return a carryover plus an element. That's a result that I want to produce. Goes to your question, we got 2 parameters in this case because, well, we are using map. Map receives, remember what for each received? For each wants a consumer functional interface. Map wants a function consumer interface. A function takes 1 input and gives you 1 output. On the other hand, reduce wants a function which can take 2 parameters and return a result. It's a binary function, right? Meaning 2 input, 1 output. So we wrote the code, but in a functional style, in a declarative style. Now what's happening? Notice the top code is called imperative code. What are the smells of imperative code? The first smell of imperative code is you use mutation. Now what happens when you do mutation in code? Bad things happen. You stay up late at work at night, eat pizza and get unhealthy, right? That's what happens when you do mutation, right? How do you make that code concurrent when you have mutation? A lot of trouble happens. Well, in this case, you can see the mutation. We first initialize total, and then we keep changing the variable total over and over and over. In fact, if you turn up the volume of the computer and run the code, you will hear the variable total say, ouch, ouch, ouch over here, right? You're constantly mutating it. Whereas in this case, no variable was tortured in making that result. The other thing about this code on the top, imperative code, has mutation, I said. The other thing is we expend effort not only to tell what to do, but also how to do it. Whereas in the code below, we didn't tell him how to do it. The library methods took care of how to do it. We simply said, here's what I want to do. So we express our intention, what to do, not how to do it. So that is one big difference, imperative versus declarative style. So as a result in this case, what did we just do? We have said, given values, flow through a stream of values, do a mapping, a transformation of every single element, and then when you do finish, reduce it to a value. Hey, what's that? Hey, that's map reduce, right? So map reduce basically says, scatter gather, take all these values, perform this transformation, and gather the results back into one that I want. So we wrote this code in more of a declarative style than the top code, and as a result, it becomes a lot more expressive. And because we are not using mutation, this code can be easily parallelized if we choose to. We'll see that later on and how we can do that. So we looked at the way to perform the mapping operation very effectively. But the question though is, how are lambda expressions really implemented under the hood? I don't have to answer that question anymore because you asked that question and we went over that. So that's exactly how lambda expressions are done pretty much at the lower level. But then there is another question that you alluded to earlier, and you said, hey, but wait a minute, you are taking that the collection and you defined a list on line number 6. And to the list you are calling a method called for each a few minutes ago. Now you're calling a method called stream. What's going on here? Because we all know one thing, right? Once you publish an interface, even the thought of changing it is evil. And if you do go ahead and change an interface, you start receiving death threats from programmers, right? Because they get angry at you that you change their interface they are implementing from, you're causing more work to it. So on one hand, we know we cannot change interfaces. On the other hand, you would agree that the interfaces they created 20 years ago, it's time for it to evolve. And so they had no way to evolve it because once you publish interfaces, you cannot touch it. Well, this gives a nice compromise. Interfaces now have what are called default methods. So what is a default method? A default method is a method implementation you can write within an interface. So interfaces can not only carry methods that are abstract, they can also carry default methods. So let's understand what that means with an example here. So we're going to take a look at how we can use default methods. And in order to understand the default methods, I'm going to go ahead and use another slightly different example here that we can build. So I'm going to go back here. Let's go ahead and create an interface over here. And the interface I create is called the fly interface. Now, what does the fly interface have? It's got a method here. I'll say public void, let's say takeoff. And I have a method here called, let's say, turn. A method here called, let's say, cruise. And finally, a method called land. So this is very familiar to us, right? We're going to be dealing with the compiler for a while. So I'll say OK to make sure the compiler is still happy. Now, look at this interface for a second. This is a very typical example of interfaces we are used to in Java, correct? Can you, in Java 7, go ahead and implement a method within an interface? Absolutely not. So my definition of interface is like this. An interface is something that says a lot about what it will do, but it never does anything. Kind of like my boss, right? So that is basically what an interface is, right? So given this interface, what do we do with this interface? Well, you can just implement it. That's pretty much. But if you walk over to one of the interfaces that you have here, and you try to implement a method, the compiler gets very angry at you, as you can see. But not so in Java 8. What we can do in Java 8 is we can quietly mark each of these methods over here as default. So by marking the methods, any number of methods, as default, now what we could do here is we could go back to these methods that we have on our hand, and we could implement the methods as we feel fit. So I'm going to say fly, and I'm going to implement each one of these methods. So in this case, I said this is going to be just printing fly takeoff. Let's say takeoff. And in this method, I'm going to simply say this is going to be a turn method. This one is going to be a cruise method. And finally, this is going to be a land method. Oh, I forgot my little strings here. So you can see how we could start implementing these methods very easily without any fear that they actually are part of the interface. So when you run the code, the compiler is still happy. So interfaces can have methods. What are the consequences of it? There are 4 rules about default methods. The first rule is default methods get inherited automatically. So if I have an interface over here called fastFly, which extends from the fly interface. How many methods does fastFly have? It's got 4 methods already now implemented. The 4 methods from the fly interface carry over automatically to fastFly. So that's rule number 1, methods are automatically inherited. Rule number 2, you can override a default method. So I'm going to say takeoff, and in this case, I'm going to print out simply, this is going to be fastFly, and I'm going to say takeoff. So you can see in this case, we are implementing that method right here in the class, in the extended class. We can certainly do that, not a problem. Rule number 2 says you can override the methods. As part of rule number 2, if you call a method that is available on an interface, if the method is on the interface, you get to it. If the method is not on the interface, it walks up the hierarchy to go to the base and gets it. That's rule number 2. Rule number 3, it says that methods in a class hierarchy rule. Absolutely no question about it. So if you have a class hierarchy, a class, it's base class, it's superclass, a superclass, a superclass. You got a hierarchy of classes, and then you have interfaces that you are implementing. It doesn't matter if a method is a default method in any of the interfaces if that method is in one of the classes in your hierarchy, right? So the grandfather has the method, cool, I'm going to use it. It doesn't matter one of these interfaces have it. So classes rule. To understand that classes rule, let's create a little bit more here. I'm going to create a class here called vehicle, and the class vehicle has a method called land, and in the land method, I'm going to simply say vehicle land. Then I create another class here called C-plane, and the C-plane extends from vehicle, but it also implements over here, and it implements, let's say, fast fly. Let's play with this to understand what the consequences of this are going to be. So now that we have all these methods available to us, we want to play with this and call it and see what it does. So I'm going to create a method over here, and the method I'm going to create here, I'm going to call it as use, and let's just call use method right here. So new sample, and then we'll say use. Well, within the use method, I'm going to create a C-plane. We'll say C-plane, and in this case, I'm just going to create an object of C-plane. Let's say equals to new C-plane. That's all I did. And let's just say at this point, I'm interested in implements. There we go. So at this point, I'm interested in calling some methods on it. So help me out here. I'm going to call C-plane dot takeoff. What takeoff is it going to call right now? That's correct. One from fast fly, because that's our nearest implementation, right? So it should call from the fast fly when I call takeoff. So I'm calling the implements on fast fly in here. If I go to fast fly, it should come to the takeoff method right here. Did it do that? So takeoff on the fly, takeoff extends fly. So when I ask for the takeoff method, it should call the takeoff method in fast fly, not in the fly. Let's see what this is doing. So that says fly takeoff. That kind of surprises me. It should be the one from the fast fly, unless I made a mistake in typing something. There you go. Very, very tricky. It still makes a good case for using the @ override, right, to avoid these kinds of mistakes. Thank you for fixing that. Good eyes. So we can see that that's the way it's supposed to work. Excellent. Well, then I'm going to call C-plane, and I'm going to say, in this case, let's say turn, and that's going to be the one in fly, right, because that's the only place where that method is. However, I'm also going to say C-plane.cruise. Well, that's a place in fly again. But when I say C-plane.land, which one will it call? Well, the one in vehicle, and the reason is, of course, class hierarchy rules, right? If a method is in your class hierarchy, that takes precedence. Please.
Does that mean that you would also never be able to create a default method from something like an object, for example, toString or hash?
So the toString methods are actually implemented in each of these interfaces as well. And because it's also implemented in a hierarchy, that rules still, but you can still go ahead and reuse those methods in the interface. I'll show you how to reuse the methods in interface in just a minute. Very good question, please. Awesome. Let's talk about that. That's the fourth rule that I've not talked about yet. All right, so what's the fourth rule? If there is a collision between methods, so let's say over here, I have an interface over here called sail. And the sail interface has a default method, and the default method is called cruise. And the default method in sail simply says, this is going to be sail cruise. So if I were to run this code now, that's not a problem so far. But if I were to say implements over here, sail as well. So now you have a collision of the cruise method, right? Because the cruise method is available in two interfaces, but it's not in your class hierarchy. Java solves this problem in a very nice way. It says it's your problem, right? So notice how you got a compilation error now, and you have to resolve it. So what you can do to resolve it is you would have to simply override that method. For example, you would say cruise, and this is going to be a C-plane cruise method. Let's just write that for a second. But typically, though, you would want to reuse the methods in the base interface as well. So we're kind of attacking both here, that his question and yours. So what you would do here is you would say fast fly, and then you would say dot super dot cruise, and you can get to the methods of the base interface through an implementation. Simply in this particular case, you would use a super word to get access to it. Now you may wonder, why are we using the word super? Why not simply say fastflight.cruise? And the reason is interfaces can also have static methods. So if you don't say super, it would think you are calling a static method. If you use the word super, it says you are calling a default method. Your question, please.
Yeah, this is cool with the interfaces. What's the advantage of this over abstract classes?
Excellent question. So does that mean we can throw away abstract classes? There are two important distinctions. Interfaces cannot have state. Abstract classes can have state. You can put fields within abstract classes. You cannot put fields within interfaces. That's one. Second, you cannot inherit from more than one abstract class, whereas you can implement any number of interfaces. So if you inherit from an abstract class, you are done with your inheritance hierarchy, no more extends, whereas interfaces, you can have many of them. So the golden rule that interfaces are better than classes, abstract classes, that rule still rules. We should still follow that rule. Good question. So we looked at the default methods, and all those methods were implemented within Java 8 using default methods. So there's a good news and a bad news. The interfaces that we have been using for the past 15 years or more, and you know some developers at company who have gotten so comfortable with Java. You could wake them at 3 in the morning and ask what methods are in an interface, and they will tell you what those methods are and go back to sleep. Some of these people are so good, they even have retired into other positions in companies, right? Those people come to work, and all of a sudden, everything has changed. That's really tough because they got to go relearn. Then there are people like people in this room. You're here because you want to learn. And this is like, yay, this is awesome. I can go back and pick up what's new again, and you can learn and get comfortable with it. The moral of the story is everything that was there has been enhanced with new stuff. So when you start coding, re-question the way you know how to do stuff, because there may be other new methods. A great example of this is a comparable interface. The comparable interface is awesome, in my opinion. Just take a look at comparable interface and look at the beautiful methods added to that interface. And it's amazing, cool stuff you can do in terms of comparing objects with those methods now and nicely compose those things together. So it's pretty nice to see that evolution. I want to show you how to implement a method that receives a lambda expression. What have we seen so far? We saw methods that we can pass lambda expressions to. But we haven't written a method that can receive lambda expressions. So what do I want to do? I want to implement a little example to show how we could actually do that. So what we will do in this example here, let's get back to our collection of numbers, if you will, and work with it. So here is my collection of numbers, and what am I going to do with these numbers? I'm going to say I want to total all these numbers. So to total all these numbers, I'm going to call a method called total values, and I'm going to say values right here. Let's take an example. Let's say this is a Friday evening. You are eager to go home from work. You got friends coming over. You're going to have a good time. And so one of your colleagues comes to you and says, I want you to write a method to total all the values. It's like, really? OK, I'll do that for you, right? So what are you going to do? You're going to simply write that method very quickly, public static int total values. And what is this going to take? List of integer numbers, let's call it. And what are you going to do within this method? Int total, right, and equal to 0. You're going to return the total value when you're done. Well, what are you going to do within this method? Well, you're going to say for element which is in values, and you're going to simply say total plus equal to element, right? So all you're going to do is total the values, numbers of course in this case, and you're going to total the values out. Great. You finish this, you look at your watch, you really are eager to go, when your colleague, the one who nags you all the time, says, I want one more method, please. Well, what do you want? I want to total not all the values, I need that too, but only even values also. You say, you mean you want both the functions? Absolutely. And you look at your watch, it's getting very late, but you really want to get this done quickly, and then you look at this code and you realize something. This code does almost everything you want it to do. Isn't that an opportunity? Absolutely. And you look at your watch again and you tell yourselves, you know what? There's got to be a reason why they created copy and paste, right? I mean, if nobody ever should use it, why would they implement it? In fact, it's so useful, they even have shortcut keys built in for us. So we could say total even values, how cool that is, right? And then we could simply say if, and then we could say the value element mod 2 is equal to 0, then total not otherwise. But as fate may have it, your colleague comes in a few minutes and says, I want one more method, odd values also. And you look at this and you tell yourselves, you're in trouble. Because you know that copying and pasting the code one more time is an act of criminal negligence. But it's Friday, nobody is looking, right? And you copy and paste it one more time and get it working, and you have that code quickly working, and you say, that's done, we can do that. But unfortunately, you know how terribly duplicated this code is. So on the way home, you realize this is really not what you signed up for. You pull over by the nearest coffee shop, try to refactor it. Some of your friends are hanging around, they ask you what you're doing, and before you could close your laptop, they look at it, they get to know your dark side. And they don't return your phone calls anymore, how life becomes, right? So we don't want to get that far. So what are we going to do? Instead, what we're going to do is, we're going to simply say, no, you want another function, sure, we can provide that very easily, but we're going to refactor this code real quick. So we want something that tells us a yay or a nay. And what is that? Well, that's called a predicate. So we're going to use a predicate. In this case, we're going to say function.predicate. And the predicate we are going to use here says, given this, I'm going to send a predicate right here, so predicate. And this is going to be predicate on integer. We'll call it selector. And all we do here is we say if selector.test the value given, if you're happy, do the totaling, not otherwise. Now that we have a predicate that we're going to send, it's also a functional interface used by filter. Now we can say, given an element, return a true, please. So you can see that did totaling. Now you can then quickly implement, given an element, tell me if the element is even. That works. Now your colleague comes to you and says, I need one more method to find if total all the elements that are odd. You say, no, go back to your desk and do it yourself, because we have made it extensible. So this is an example of a strategy pattern, as you can see, but we used interfaces, functional interfaces to do this rather than anonymous inner classes. So getting back to this code, you can see how we are doing predicate in this case. Of course, we could quickly change this code. We could say return. After all, we are totaling the value, so values.stream. And then we could say right here, I want to filter the value based on the selector, because the filter is accepting a predicate after all, right? And then now we can do a reduce operation on this and perform the total. And there are other implementations for this. This is just one example here. And we can simply say return the carryover plus the element over here. So notice how we turn that code into more of a functional style code as well, very easily, as you can see in this case. Oh, one quick fact right now, notice how I'm lining up all these ducks, I mean the dots, right? So you need to keep those all lined up so it's easy to follow what kind of transformation your code is going through. So that is an example of how you can implement receive functional interfaces. But when you're receiving functional interfaces, now your code can send to you lambda expressions. A quick note, I have a client who is developing application which both Java 7 clients and Java 8 clients are using. So what they have done is they have started publishing functional interfaces. Java 7 people are sending anonymous inner classes. Java 8 people are sending lambda expressions. So it's a double win situation, right? So your code could be ready for receiving lambdas even if you're not in Java 8 right now. And then once you switch to Java 8, it works just like that, right? Without much effort at all. Please. The reduce takes an initial, like what is the beginning value, a seed value you want to start. It's a fold operation, so the C becomes 0 to begin with. E is the first element. The total of those gets returned. The C becomes the result of the previous call. E becomes the following element. So it just progresses that way to find the result. So this is purely a fold operation. The first time C is 0, second time C is the result of the previous call, and so on. So now that we have seen that, let's talk about composing with lambda expression real quick with another example. So, yes, please. Could we inline the selector on what line number? Line number 7 or 6? 8. When you say inline, I mean, can you put a lambda right there? Well, you cannot put a lambda here because you're receiving a lambda. That's a strategy pattern. You want them to tell you what the strategy is. You want to do the rest of the work. Like, do you want, what kind of drink you want? I usually would ask you. I don't want to provide you a standard drink, but you have the option of having a drink, right? So that's a strategy. You tell, I want even, I want odd. So you send the selector, and it does the rest of the work. You can inline it, but then you don't give the option of selecting at that point, more than that value. Let's look at one other example here. Let's say we're going to define this a little differently, and for this, I'm going to restructure this just a little bit. Let's say 1, 2, 3, 5, 4, 6, and let's say 7, 8, 9, and 10. So I got a bunch of values on my hand. What I would like to do here is I want to find the double of the first even number in the list. So this is what I want to find, the double of the first even number in the list. Shall we try? So int result equal to 0, output result for int element in values. And what am I going to do here? If element is greater than 3 and element mod 2 is equal to 0, then result is equal to element times 2. Is that good? You want a break? I got only 20 more minutes to finish the talk. Oh, a break in the code. Okay. So a break. Does that work? Notice you went from, no, it doesn't work, to, I'm thinking. Actually, this code is broken. We don't know why it's broken yet. And this happens all the time at work, right? You release a code, 2 months later, the guy walks in, the tester, and he says, hey, your code sucks. You say, I know it, but tell me how it sucks today, right? That's what we normally want to know, right? So this code is broken. We don't even know how it's broken, right? Well, rather than saying how it's broken, let's re-implement it this time. I'm going to say output, but this time I'm going to say, given the values, get me a stream. And what am I going to do? Filter. And what are we going to do with the filter? I'm going to say filter, given an element, return to me element is greater than 3. Great. And what else am I going to do? I'm going to do a mapping. Am I doing a mapping? No, I want to check another filter. Given an element, tell me if the element is even. Then what am I going to do? Mapping. And given an element, double the element. And then what am I going to do? Return the first, find first. Right? So run the code and, find first. Find first, right? So run the code, and this code is very revealing. The code that you see up here is imperative. Imperative code has mutability, it's got low-level construct, and it hides truth from you, waiting to hurt you. This code reveals the details. When you run this code, notice the output. It says optional 8. And some of you are already probably thinking, of course. Why is it optional? Because the given input may not have an even number at all. It may not have any even or a number greater than 3, right? And this guy says, let me be very straightforward with you. This is going to fail if you try to get it. So here's an optional. It removes the null pointer exceptions. Whereas the top code, the tester who came in said, I got the collection of input but didn't have any even, and your code returned a stupid 0. Right? Whereas here, oh, of course, what do we do with it? Well, of course, you want a specific result. Maybe you want a 0. How do you do that? I do have to admit to you one thing. This is probably the scariest function I've seen in the JDK. It is called or else, right? And then you can say what you want to do with it. Very threatening, right? So you can say, if it doesn't exist, give me a 0. So you can give optional values with a substitute value if you want to. Looks so far so good? Please. With the AND operation? Well, you could, but that would be a little smelly. Yeah? Any other questions? Yes, please.
Why do you have to test whether it's greater than 3?
Because the problem statement said it wants to. So I wanted to find the first even number greater than 3 and double it. That's why. Yeah, please.
Does that map contain all the values?
That's correct. And
That means it has to compute all the values.
So you're being very polite there. You're saying, you know what, this sucks, right? That's what you're saying, right? Because all I wanted is the first value. I had that beautiful imperative code that was performance, super performance, and you're telling me that this is elegant and its performance sucks. Are you out of your mind? Is that what you're saying? Yeah, okay, all right. So that's what he's saying. That's a really brilliant question, right? Because we went from, let's say, 10 values. Can you do me a favor? You, sir, who asked the question, can you do a count for me? All right, you're ready. So in the old code we did, this one here, this one. So how many are we doing? So here we go. We're doing a test for 1. So 2 tests for 1, a test for 2, a test for 3, a test for 4, I'm sorry, 5, a test for 4, and then we stop. Because the minute we test 4, we're not going to do anything more, right? So that's about 8 operations, right? But in here, it appears that we're going to do the following. Here's your count. We're going to do filter for all the 10 values. That's 10. Keep a count. It's already failed, right? 10 is greater than 8. Then on this one, we're going to do filtering on everything greater than 3, which is 7. 10 plus 7, 17. This is going to do mapping of all the even values. That's 4. 17 plus 4, 21. Plus one more, 22 methods, right? Wow, that seems heavy. Well, I forgot to mention one thing for you. There's a feature of streams that's very important to think about. And I've only seen this characteristic of stream being shared by my children. They both are lazy to the bone. My children are working over there, having fun, they're doing some stuff, fighting with each other, and I say, are you done with your homework? Yes, Daddy. How did it go? Fantastic. Were there any concerns? No, everything worked. Can I see the results, please? Sure. And then I don't see them for a long time. And I asked my wife, where are the children? Did you ask for the homework? Oh, yeah, they're working on it. So in this case, you go to the stream and you said, stream, yes, filter, done. Filter again, done. Map, done. Find first, oh dear. I got to get some work done, right? So let's see if that's true. So what I'm going to do to understand that is, let's get rid of this old code for a second. And what I'm going to do is simply rewrite these a little bit, if you will, so we can actually easily see this. So public static over here, int, we will call it a Boolean, and we will call it as is even, and take a number, and it simply says return number is mod 2 is equal to 0, right? Very simple. Let's also write a few other functions. This is going to be is even, is greater than 3, and all that this does is greater than 3. This is going to return an integer, we'll call it as double it, and this is going to simply return the number times 2, and I think that's all I need. So now let's do this. I'm going to go back to this code, and I'm going to simply say this is sample is greater than 3. This is going to be the method class sample is even. This is going to be the class sample and double it, right? So go ahead and run it, and it still produces a result. However, this time, I'm going to go back here and simply say is even for, and let's say number. Let's go back here and say output is greater than 3 for and number. And then finally, I'll say output double it for, let's say, number. Now, when I run this code, notice the number of operations is actually performed. It actually ended up performing exactly that 8 operations you agreed to on the other version. Why? It first said, I'm not going to run through all of these. Methods like filter, map, and all that are called intermediate functions. They are lazy. They don't do any work. The method like find first are called terminal functions. Those trigger the computation. And the computation only happens enough to get the work done. And so all these methods get fused into one ball of a function. The intermediates fuse together, so they are executed only once. And going back to your earlier question, somebody asked over here, can I put 2 ends in there and combine them? Well, that's exactly what it did for you. We didn't have to do it extra effort. So the code looks beautiful, and it also is very performant, as you can see. So it's a win-win situation. We get the best of both worlds. So that is the benefit you saw here, is that these are done lazily. Just to prove this real quickly, notice if I do not call find first at all, right? I did not call find first. I stopped shy of calling find first, And so I did not do find first. Actually, let's do it this way. I'm going to go back here and say dot find first. So I called the find first, and you can see that output. But I'm not calling find first. What's going to happen now? I'm running the code, output here, and notice it never did the work. This is like the day at office when the boss is not around, right? It's like, why bother, right? No need to do any work. So those functions never expended any effort, so they're not creating collection after collection after collection because that would be very inefficient. This is, by the way, this is called lazy evaluation, but in Java you don't use the word lazy, you use the word efficient, right? Because that's what it really is. You just write it with the 4 letters, but it's pronounced efficient. So that is the benefit we saw so far. But I want to go through one other example here to illustrate how this can be very helpful. So this is the last example I want to create here. What I would like to do is, I want to go out and compute certain things for us. So I want to say, get me the highest stock price, less than $500 from what? From tickers.symbols. So I got a symbols. Among all these ticker symbols, I want the stock which is less than 500, but which is the highest. So we're going to do this in 2 different ways. We're going to do it like the way we have done it before, using the imperative style first. Then we're going to do it with functional style and see what the difference is. Sounds reasonable? All right. So what are we going to do? The very first thing I'm going to do is list of stock info, stocks equals new array list. Now, what is this stock info? Let's take a look at a stock info for a second. So if I go to stock info, you will notice it's just a POJO. It's got 2 final fields, ticker and price, a constructor to initialize it, and a toString method to print it. Fair enough? Nothing intelligent in this particular class. Now that I have this collection, I'm going to say for string, we'll call it symbol in, and I'm going to say this is going to be tickers.symbols. And actually, I'm going to write this in a separate method. So we'll call it as public void find imperative. So we'll say imperative. And this is going to take, let's say, a list of string. We'll call it symbols. How about that? That's easier to work with. So we got the symbols that's given to us. So symbol in symbols. We're going to just use that method right here. And once we call that into symbols, what am I going to do? Of course, I want to call this method here, and I'm going to measure the timing of that. So we'll make this a static method for convenience, and we will go ahead and say time it dot code, and I'm going to just time the code, how much time this code takes to run. So find imperative, and I'm going to say tickers dot symbols. All right. So what is this code going to do? How much time it's going to take to do it? Well, it doesn't do any work right now, so it doesn't take a whole lot of time. But what am I going to do within this function? I'm going to say stocks.add. Well, I need the price of the stock. So I'm going to say stock util.getPrice, and I'm going to specify the symbol to it. Let's take a look at stock util. Stock util has a method called getPrice that takes the ticker symbol you provide, and it goes to Yahoo Finance and finds the price of the stock and returns the stock info with the ticker symbol and the price. Hey, what does the getPrice method do? It just makes a request to the web service and parses the data. It is unethical to show parsing data in public. I will not do that here, but you can take a look at it later on if you want to look at the code that I've provided. So all that is doing is just returning that information, right? Okay, great. Well, now that I have the symbols on my hand and the prices, I add it to the stock. What's the next step? List of stock info, and this is going to be stocks less than 500 equals new array list. Great. And what's the next step? I'm going to say for string stock info, and this is going to be stock in stocks. This time, if stock util dot is price less than 500 dot test stock, then stocks less than 500 dot add the stock. Let's take a look at is price less than 500. This takes a double value, but it actually returns a predicate itself. This is a function that returns another function. So you can use that function later on. So it's like, now rather than giving somebody a fish, you give them a fishing lesson, right? It's kind of like that. So here, take this function with you. You can keep calling it. So that's all this method does. So we get the test method, and we call that, and then we test it. So that gives us all the stock values. What's the last step? I'm going to say stock info. In fact, I'm going to do this here. I'm going to say public static stock info dummy equals new stock info 0, and the price is 0, and there's no name for it. So I'm going to say in here, the last step, stock info high priced equals dummy. And for this is going to be a stock info stock in stocks less than 500. And what's the last step here? If so, stock high priced equals stock util dot pick high from the high priced and the stock you have on hand. Let's look at pick high. Pick high takes two stock info and returns the one that has the bigger price. As simple as that. So now that we have seen that, let's go over the code one more time. Oh, we got to print the result, don't we? So output over here, high priced. So what did we do? We took all the stock symbols, found all the stock prices, took all the stock prices, and found all the prices less than 500. Took all the prices less than 500 and picked the high priced. Make sense? Okay, let's run this, and while it's running, we'll talk a little bit more about this. Oh, wait, what line number did I make the mistake? Line number 15, let's fix that. So stocks less than 500 dot add, and I'm adding a stock over here. Does anybody see the error that I made here? So this is going to be test the stock, and if the stock is valid, is less than 500, go ahead and add it to stocks less than 500 and add the stock. It said something about a symbol. Oh, some character, funny. Okay. While this code is running, what does this code do? It goes to the web, finds all the prices for the symbols, finds those less than 500, picks the highest among them and gives it to you, right? Fair enough? How could we improve this code? Well, there's a way to improve this code right off the bat. I know you are telling this, right? Why have 3 loops when you can have 1? Absolutely. You could shrink all of that to 1 loop. Well, that 1 loop will do everything, but it'll be short. Hey, but the code won't be readable. But that's no problem. We never read the code. We only write it, right? So it would be a mess to deal with, right? How much time did it took? About 25 seconds with me. What's the stock that's the most priced among those? Amazon at $331.33. Could somebody note those two for me? We're going to re-implement it, and we'll see if we're close to it, right? Thank you for your help. So we're going to, and somebody can check to see if the price is true as well. Absolutely. Go for the web and see if it's true. But please note that down. That's the Amazon price, and that's the time. But we're going to write this in functional style, shall we? So what I'm going to do, let's forget that call. I'm going to say timeit.code. And this time, what I'm going to do is simply call over here, find functional. And this time, I'm going to say tickers.symbols.stream. I'm going to send a stream to it. So let's try it. I first need a stream. So let's say .util.function.stream with me. Let's go ahead and try it. So I'm going to say the function we're going to write. Oh, before we do, how many lines of code do we have in the imperative style? Oh, about 26 minus about 7, say about 20 lines of code, give or take. Of course, we could have shrunk it into one method, but we talked about the consequences of doing that. Okay, try this again. Public static, and this time I'm going to say find functional, and this is going to take a stream of string symbols. And I need your help here. I'm going to output, we got all the symbols on my hand, but I need all the prices for it. I wonder what method we could use. Thank you, map. So to the map, I'm going to say stock util : get price. Make sense? because that's a method we are interested in calling, isn't it? You can compare line 16 to line 9, right? Because remember what we are doing in line 16. All we are doing is passing that parameter symbol, right? Well, that's an office space pattern, so we can use a method reference for it. Great. Now we have all the prices, but I only want prices less than 500. I wonder what we could use. That's correct. A filter, stock util is price less than 500. Remember, this was returning a predicate. We can just pass that. Great. We have done the mapping, we have done the filtering, but we want to pick one value. I wonder what we could use. A reduce. So reduce dummy value, but this is going to be stock util pick high. With me? Is that more concise? Absolutely. Does it flow through naturally? You can actually read the problem statement and understand the code and vice versa. If somebody comes to you and says, hey, I'm the domain expert, could you explain to me what this code does? What do you say? I'm trying to figure that out too. If you sit with the domain expert and say, what does this code do? You say, dude, given all these symbols, we get all the prices, we pick less than 500, and we reduce it. Questions? It begins to read like the problem statement, isn't it? So let's run this and see what happens. So if we run this code, well, it better be the same price, and it better be about the same time as well, isn't it? So it shouldn't take any more time than it should otherwise. So let me see where the error is. I probably made a typo error here. Let's fix that quickly. This is, pardon me, this is stream.stream. Okay. So I'm running this code, and this time we're running the functional style code rather than the imperative style code. And so what did we do? We said, given this value, find me all the prices, and then find the values which are less than 500, and then give me the stock price that is the highest. The time may vary a little bit depending on the internet connection, how many people are trying to get on the web and do stuff with the wireless. But of course, that depends on how it's going to work. Is the time about the same? Is the stock price exactly the same? Yes or no? So sad story. Just because you write functional code, you don't get better stock prices. Right? It feels better, you're saying. Okay, all right. So it feels better. All right, that's even better. So far, so good? So what did we do? We can write code in a much elegant way. But there are some things we did really well. We did functional hygiene. We didn't go around and sneak around and modify global state. We didn't mutate variables. We nicely formulated these calls around, right? You say, okay, that's all great, but is that it? We're done, right? No, there is one more thing. Let's go back to this code for a minute. What does this code do? It works sequential, goes one time at a time. And what is the slowest part here? Going to Yahoo, not because of their problem, because of my poor internet connection, right? And so what's going to happen? Well, let's say we have a lot of stock prices to work with. And one day, the tester walks in and says, your code sucks. It's like, what again? What did we do? Well, I'm running with these 150 values, and it's taking way too long. It's slow. You got to make it faster. And now you're looking at this code, the sequential, the imperative code you wrote. Remember that? Do you think it would be easier to fix the code if you push them all together into one loop? No, it's even worse, right? And you're going to look at this and you're trying to think, how do you make this faster? How do you make this faster? And while you're thinking about it, one of your colleagues says, hey, I got a great idea. And you're like, uh-oh, what is it? Well, remember how we have multi-core processors? We could make this code concurrent. And immediately you think of what happened on your last work, the job you quit. Remember that? You had an application that was sequential, everything worked fine, and one day they said we want to make it multi-threaded, so you modified the code, and when you modified the code, did it look like the sequential code anymore? No, it turned into a monster. And it was buggy, nothing worked. And while we were trying to debug that code, you applied for the next job. That's called concurrency. Right? You're like, oh, nope, not me. Don't want it, right? Well, what if the code structure is exactly the same, to go from sequential to concurrent. So you're looking at this code and you're saying, you know, wouldn't it be nice to make this code concurrent? Wouldn't it be really nice to make this faster? Wouldn't it be nice to really get some performance out of this code? That would be really nice, isn't it? And so what did we do? All we did was we changed that code from stream to parallel stream, and we said, go get it. So remember, I promised about polymorphism in the beginning when I started this talk. I said, let's seed control. Don't worry about how to do it. Focus on what you want to do. What did we say here? We said, I want to do this work. Hey, do you want to do this work sequentially or concurrently? I don't want to commit to that decision now. I want to do this. That's it. Whether it's sequential or concurrent is an execution engine. Logic is different from the engine, right? So we have a master switch on our hand, and the master switch here is, do you want to run it concurrent or do you want to run it sequential? So we are running sequential, we're doing concurrent. Why have that master switch? The master switch gives me the power as a programmer. Here, sequential, flip, turbo mode, flip back. Why do I have that control? Because I know when it's the right thing to do. If the problem size is very small and I use concurrency, I spend more time spinning threads than getting results. It makes no sense to use concurrency. Sequential. Oh, look, I just checked on the input size. That's large. Flip over. I'm on the turbo mode, right? So we have a master switch to go back and forth as we feel fit, please.
When you do run it concurrent, how does it know how many threads to run it?
Great question. So right now as it stands, it makes that decision based on the number of cores you have on your machine. There is a switch you can use at the JVM level to reconfigure that. But you cannot do that programmatically today because they don't feel comfortable giving that power to us yet. But I'm hoping, if we all behave nicely and use this really well, maybe we'll get that programmatic functionality. I would be surprised if we don't have that in the future, but we don't have that right now. But you can change it at the JVM level, and you can also change it, of course, based on the core. Please.
So then the other question was, if you've got multiple processing strings going at once, are they going to be using like the same thread pools in the back end?
Yes, but it's going to be work stealing, right? For join API, so the power of that is going to be there. So what we saw here was a very simple ability to go back and forth and make use of it. So to summarize what we talked about, we looked at the facilities of functional programming that's available in Java 8. And one of the statements I want to say here is, I looked at lambdas, and I was not too excited, honestly, because lambdas are nothing new to me. I've seen that in other languages. But the minute I got into Invoke Dynamic, the minute I got into streams and the laziness, I was hooked on. So I'm going to say that lambda expressions are the gateway drug. Streams are the real addiction. And I have every right to say that because I come from the state of Colorado. So the point really is that you can really optimize on this and make it better. It reduces the amount of code you have to write. Michael Feathers once said that object-oriented programming encapsulates the moving parts. Functional programming eliminates the moving parts. What a great way to think about it, right? Rather than encapsulating the moving parts and suffering through it, you are eliminating the moving parts. So by having a functional hygiene, you want to make sure the functions are pure. You don't cause side effects in them. And those are the things we need to take care of. Java will help us along some way, but we got to have the functional hygiene, not introduce side effects. And then once we do that, we can make sure that we can formulate this as function composition. And when we do that, it becomes easier for us to express the problem because the code begins to read like the problem statement. It becomes a well-written code is easier to optimize for performance. A poorly written code, it causes ulcer, right? So the point really is that we can actually write better quality code, and as a result, we can improve it. And so overall, it is definitely a great step in the right direction. And anybody who is developing Java applications, as they move into Java 8, they can very readily start using it. IDEs are supporting the features already. So if you turn on your IDE and say, I'm using Java 8, they start giving you flags to refactor your code to more functional style. But finally, I'm going to say, sure, the language has evolved. Sure, the syntax has changed a little bit. Sure, the semantics has evolved quite a bit. But I'm going to say the biggest change in Java 8 is in the minds of the programmers. And it's a lot of fun to be learning a better way to program. I really hope you found this useful. Thank you.